This video will show you how to use the curve estimation technique to isolate which variable needs to be squared when you have a curvilinear relationship. Here is my data set. I have grade as my dependent variable. I have two independent variables, anxiety and hours of homework. These variables have already been centered. I will run my linear regression and test the linearity assumption. Regression, linear, grade, anxiety centered, and hours of homework centered are already in the program. I'll go to plots, put in zpred in the x variable, zresidual in the y, continue, paste, find my syntax, and here is my residual plot. A definite frown exists in the data. This shows me that there is a curvilinear relationship in my data. But it does not show me where the curvilinear relationship is. It could be in either of the independent variables. It could be in anxiety, and it could be in hours of homework. I do not know which one it is from looking at the residual plot. To isolate where it is, I go to Analyze, Regression, Curve Estimation. I put grade as a dependent variable, and I'll put hours of homework centered in as the independent variable. I'll check both the linear and the quadratic. There are many different options you can choose. If you wish to have a more detailed information of what these things are, what types of transformations these things are doing on your x variables, you can click on Help, and it will bring up and click on Curve Estimation Models, and it will tell you what different types of transformations it is doing on the x variable, such as doing a logarithmic, an inverse, or a quadratic. For our purposes, we will just test the quadratic. So going back to regression, curve estimation, linear, quadratic, hours of homework, predicting grade, paste, and I see a scatter plot where hours of homework centered on the x-axis and grade is on the y-axis. Notice I have these discrete lines. This is because hours of homework were reported in hours. Either the hours were 0, 1, 2, 3, 4, 5, and so forth. Therefore, I don't have any decimal places to fill in these discrete values. That is fine. The regression will work just as well in this case because we have a lot of different categories of hours of homework. Nevertheless, I have two lines on my curve estimation plot. I have the solid line that shows the linear relationship between hours of homework centered and grade. I also have the quadratic line, you can barely see it, that shows what a quadratic relationship would be between these two variables. These two lines overlap almost exactly. If I put a fat pencil over my linear line, it would cover both the dotted line and the solid line. Therefore, there is very little evidence that there really is a curvilinear relationship between hours of homework centered and grade. Let's try it with the other independent variable, which is anxiety. So I'll take hours of homework out and put anxiety centered in. Click paste. Run it. Look at that. I have the straight line and the curved line. If I put a fat pencil over the straight line, it would not cover both the curved line and the straight line. This is evidence that the squared or the curvilinear relationship lies between anxiety-centered and grade. So let's go ahead and create that variable and rerun the regression to see if it resolves our problem. So I go to transform, compute variable. My target variable would be anxiety-centered squared. Put anxiety in, times it by itself. This will allow a quadratic relationship to be estimated in my data, a parabola instead of a straight line. Go to types and label, use expression as label, paste, find the syntax, run it. I have a new variable in my data set called anxiety-centered squared. Double click on 2. If I square 0.08, it will probably equal to 0.01. If I square 1.5, negative 1.5, we'll probably get 2.33. It looks like it worked. Let's go ahead and rerun my regression with all 3 of these independent variables. Analyze, regression, linear. I already have anxiety and hours of homework. I only need to put in anxiety-centered squared in addition to the 2 previous ones. Paste. Syntax. Run. And look at that. My residual plot now has no smiles or frowns. I have resolved the curvilinear relationship in my data using curve estimation to isolate which of my independent variables the curvilinear relationship lies.